we are going to start 6.8, which does the graphing of radicals and their translations. So if you recall, we originally started with parent functions, and we talked about translations back in chapter 3, like forever ago. One of them we started with is if we had the parent function y equals the absolute value of x. What shape does that make? A V, good. And so we said that the translation form of that was y equals a, absolute value, x minus h plus k. And we said that the h tells us whether we're going right or left. K told us whether we're going up or down. And A, whoops, let's write this as, if A is positive, it opens up. If A was negative or less than 0, it was a flip. If A was greater than 1, it was a stretch. And if A fell between 0 and 1, it was a compress. Does that sound familiar?
Sure. Yeah.
Okay. After we did the absolute value of x, we went to y equals x squared, which was a parabola. And then we went to its translation or vertex form, which was y equals a x minus h squared plus k. Or again, what does the a do? Perfect. Thank you, Emma. What does the h do? Left or right. And what does the k do? Up or down. All right? You guys remember doing that, correct? A little bit? Okay. So, let's just go back to that time, that era. Done. Bring it all back up here. If you were given y equals negative 2, x minus 4 squared plus 7, what happened to this parabola? First of all, that negative told you it was a flip. Oh, got to go back to this 2. The flip is the negative. The 2 is a stretch. Then inside this parenthesis, you technically set that equal to 0, and you get right 4. Yep, and then up 7. So if we were to graph this before, you went right 4, 1, 2, 3, 4, up 7, 1, 2, 3, 4, 5, 6, 7. You were flipping it upside down, and it was a stretch, so it was skinnier, right? Remember that? Okay. Using those same ideas, those same rules we did before, we have a new parent function to work with. Today's parent function. The first one we're going to work with is y equals the square root of x. The square root of x is a graph that starts at the origin, because you can't go to the left at all, it can't be negative. Starts at the origin and is like a side, one half of a parabola, so to speak. So if I were to put 4 in for x, it goes up 2 spots. Right? It does this curve. So if I were to take that exact same thing, the square root of x, and subtract 2 from it, what's going to happen to that curve? Down 2, exactly. So that means that my same thing, if it moved down 2, it's the same curve, just shifted down 2. if I had y equals the square root of x, and underneath that square root, I had, how about plus 3? Left 3, very good. Left 3. So my curve here would go 1, 2, 3 to the left. Start right here and be the exact same curve. I went a little high. Same concept, exactly. No. All right, so really our translation formula, let's put it all together, would be y equals a, the square root of x minus h, and then plus k. Where, of course, a, if a is less than 0, it'd be a flip, be the bottom half of that parabola. If a is greater than 1, it's going to be a stretch. And if a was between 0 and 1, it would be a compress. For the h, you technically would take x minus h and set that equal to 0. And this would tell you whether you go right or left. And of course, my k tells us whether we're going up or down. All right, we're still good? All right, so here's example number 1. For example 1, this is going to cover your 8 through 14. Now, I'm going to give you directions a little bit different than the book. We're all listening, right? Okay, the book just says graph. What I want you to do is not graph, but I want you to sketch and describe. All right? So if you were graphing, it'd be more precise. What I want is you're going to describe it to me, and then you're going to draw a sketch so you show me that you understand where it should be. But it's not exact, okay? If I wanted an exact graph, what would I probably do? Put it in the calculator, right? I would grab that technology I have at my fingertips and put it in there. All right, so here we go. First one, let's say I have y equals the square root of x plus 4. So first thing you're going to tell me is this goes to the left 4. Then you're going to draw me a little graph over on the side. You're going to go 1, 2, 3, 4. This is where my curve starts. Curve up. Boom, done. All I'm looking for. Okay? Example number 2. Example number 2, this is going to do 16 through 20. Again, although it says to graph, I really want you to sketch the translation. So you need to describe it to me and sketch it. So we're going to do more than one thing this time at once. Let's say I have y equals 3 square root of x minus 1 plus 4. Yes, this is a stretch of 3.
So to stretch this, this makes it straighter, correct?
No, it brings it more of a curve.
Oh, okay.
Okay, it's going to hype it up higher.
Straighter, stretch makes it curve.
Yeah. So you can think of it as it's like grabbing the top of the curve and pulling up. You're stretching it up. If I want to compress it, it's like standing on the top of that curve or that mound and pushing it down.
Oh, yeah, I know. This is reverse of.
Yes, exactly. So, and this is up 4. So when I go to sketch this, go right 1, up 4. So it's going to start right here, and it's going to be more of a curve because it's a stretch. Seems pretty easy? Good. Exactly. So, I'm going to jump to the next part then. I got one more parent function I want to talk about. Y equals the cube root of x. Okay, so first of all, you need to know what the cube root looks like. The cube root, remember that your cubic function was our S curve, right? Remember that, I'm going to throw it up here. The cubic function did this. So this is a reflection of that. Okay, so your cube root function does this. So it's a sideways S. It's like the top of a parabola on that side and the bottom of a parabola on this side. Okay? So then here is example number 3. This will be your 26 through 30. I skipped over 1, which I'll talk about in a minute. All right, so again, I want you to sketch, even though it says graph, and describe. All right, so let's say I have y equals, let's go with the cube root of x plus 2 minus 4. So what does this tell me we're doing? Good. Good deal, you guys. Awesome. So, on my graph, as I sketch it, my center goes to the left 2 and down 4. This is going to be the center of my S. So I just want you to sketch the upper part on this side and the lower part on that side. That's it. Not precise, but it gives me an idea you understand how that moves, right? Okay. Last thing I want to talk about is number 22 and 24. So 22 I want to talk about. 24 you guys can do.
Example 4.
Yep. Example 4. This is actually number 22.
Okay.
It's going to ask you to solve by graphing. Again, this is something you've done before. If I give you something that looks like this, or the book gives you something that looks like this, let's say you have the square root of x minus 3 equals 12. Can you solve that algebraically?
Sure. Yes.
Yes, you can.
All over.
No.
X minus 3 equals 24.
Correct. So if we were going to do it algebraically, we'd square both sides,
Sure.
and then we'd add 3 over, right?
So, yeah.
Okay. If you're doing it graphically, and I'm okay if you want to solve it algebraically, totally good with it. If you want to do it graphically, what that means by the directions in the book is that this goes in the first y equals, so y equals the square root of x minus 3, and this goes in the second y equals 12. Algebraically, yep. So, if I get this, this says I have a square root function that does this, and then when it just equals 12, it's a horizontal line that does this.
So where they cross.
It's where they intersect is your solution. Again, it's stuff we've done before. I just want to explain the directions of what your book is trying to ask you to do. Okay? So you can solve it algebraically or you can solve it graphically. Is there any question? Awesome. So you guys have like 7-8 minutes. I'd love for you to get a lot of this done. Okay? I think it'd be in your best interest to get started right away. Right? Let's get going.